All right, time to talk about some proportions. The sampling distribution of the sample proportion. So first, let's talk about proportions in general. A proportion is a fraction or a percent of the total that possess a certain characteristic. So if I say 23% of people have blue eyes, 23% is the proportion that have the characteristic of blue eyes. So when we're talking about proportions, the symbols that we're going to use for the population proportion is a lowercase p, and the symbol that we're going to use for the sample proportion is a lowercase p with a little hat on top of it. So I know these look incredibly similar, and I'm sorry about that. I did not decide what the symbols were going to be for these. This is the one symbol where the parameter is not a Greek letter that we're going to see. It's a normal letter, and it doesn't even have anything fancy with it. But the statistic, the sample proportion, does still have a little extra thing on top of it. So parameter population proportion is P. Statistic sample proportion is P hat. And that's how we read this right. P hat. So let's look at how we calculate a proportion real quick. So a Harris poll was conducted for 1,200 adult Americans who are vacationing during the summer, and they asked whether they plan to work while they were on vacation. Of those that were surveyed, 552 said they plan to work while on vacation. Find the sample proportion of individuals who plan to work while on vacation. So when we're asked to calculate a sample proportion, P hat, we are going to calculate that by taking X divided by N, where N is the sample size, as it always has been, and X is the number of individuals with the characteristic that you're looking at. So in this case, the characteristic that we're interested in is the people that are working while on vacation. So our P hat, our sample proportion, would be 552 over 1,200. And that's 0.46. You do not want to turn a proportion into a percentage, because in the next step of what we look at, the next thing we're going to look at, you're going to start doing math multiplication with this. And so if we turn this into 46%, I'm just going to have to go back and turn it back into 0.46. So just leave proportions as decimals, unless you are specifically asked to turn it into a percentage. Do not even bother turning your proportions into percentages. You're just making more work for yourself. So now the sampling distribution. So the sampling distribution is looking at all possible sample sizes of size N and looking at the sample proportion from that sample size. So this will be approximately normal if, and the formula that I'm going to give you is going to differ slightly from the one in your textbook. So if you're using your textbook and you compare this to that, this one's going to differ slightly, but the one I'm going to give you is the one that is more widely used in the statistics community. The one from the textbook, if you've been using that, is a dumbed down version that I don't like. So we have this sampling proportion of all possible sample sizes, looking at the proportion from that sample size, is normal if your n times p times 1 minus p is greater than or equal to 5. So this is where n is the sample size and p is the population proportion. So if you do this multiplication and the number that you get is at least 5, then you have a normal distribution. If it is smaller than 5, then you do not have a normal distribution. So once we determine if we have a normal distribution or not, the mean of that distribution, if it is normal, the mean of that distribution of all possible p values, p hat values, is going to be equal to the population proportion p. So this is the mean of the sampling distribution. And then the standard deviation of the sampling distribution, that's not what I meant to write, of the sampling distribution. I'll also say the standard deviation of p hat a lot. That is the square root of p times 1 minus p divided by n. And notice, I'm going to rewrite this line and that line. This is all in the square root. So the mean of the distribution is equal to the population proportion, and the standard deviation, the spread of this distribution, is found by taking the square root of p times 1 minus p divided by n. So then if I have a sample proportion and I want to figure out how far away is my proportion from the mean in terms of the standard deviation, I want to find the z-score, I'm going to take my sample proportion p hat minus p, which is the mean of this distribution, and I'm going to divide that by p times 1 minus p divided by n. And then if we're working backwards and we've been given a probability associated with a sampling distribution for a proportion, and we're being asked to find the p hat or the sample proportion that is associated with that probability, then we would take the z-score times p times 1 minus p divided by n, square rooted, plus the population proportion p. So these are all of the values and equations that you are going to need for the sampling distribution of a sample proportion.